Mr. Corsey here. In this question we're shown a box of chocolates with a hole in the middle and various dimensions given. We're going to start off looking at this information. The volume of the box is 2000 cubic centimetres. So that's the whole box minus the hole in the middle. So let's have a look at the volume of the box as it is. How would we find that? Well, we'd find the volume of complete box minus the volume of the tunnel. They call it the tunnel in the middle. So what's the volume of the complete box? Length times breadth times height. Length 3x times breadth 3x times height h. Remember, it's a square base, square top. 3x times 3x times h minus volume of the tunnel, square top. Length x, breadth x, height h. Length times breadth times height. X times h. So let's simplify this. 3 3 is 9. X times x is x squared times h. 9x squared h minus 1x squared h. That'll be 8x squared h. So we now know that 2000, which was the volume of the box, 2000 cubic centimetres, is 8x squared h. Now if we look at what we're asked to show, we're asked to show the surface area of this, which is a fairly complicated job, but the surface area and the expression they get does not involve h. This relationship that we've got allows us to find h in terms of x. If we divide both sides by 8x squared, and there's a bit of cancelling that can be done, and we end up with 250 over x squared. There's 8 lots of 250 make up 2000. So it's 250 over x squared. That's an expression for h. Let's work out the surface area. And it depends on x. So let's take it in stages here. Let's take the top face and the bottom face. I always set this out. There's a top face and a bottom face. They're identical. There's 4 sides, which are all identical. And then, of course, there's 4 inside faces. And they're all identical. So there's the top and the bottom, that's the ones with a hole in it. There's the 4 sides, and then there's 4 inside faces, the sides of the tunnel. So let's do this. Top face, bottom face, they're both identical, so there's 2 of them. The large square would be 3x squared, 3x times 3x, that's 9x squared, minus x squared, the whole in the middle, x times x. So there's 2 lots of a 9x squared minus x squared. And then there's 4 sides, each side being 3x times h, 3xh. And then there's the 4 inside faces, each of them is a rectangle, x times h. So let's see if we can sort this lot out. 9x squared minus x squared is 8x squared times 2 is 16x squared. Well, we're good with that. We've got that part of it. The next part, 12xh plus 4xh is 16xh. But you see, we did manage to find out what h was in terms of x up here. So we can replace h by 250 over x squared. So we have 16x squared. Now, one of these factors of x can cancel. X into x goes 1, x into x squared. It just leaves one of the factors of x there. Remember, x squared is x times x, so one of these x factors cancels. And remember, 8 lots of 250 was to 2,000, so 16 lots will be 4,000. So we have 4,000 over x. And that's what we were trying to prove. The area, surface area of 16x squared plus 4,000 over x. So that's part A of the question completed. Let's have a look at part B. We're told that to minimise the cost of production, the surface area, which is given by this expression in terms of x, of the box should be as small as possible. And we have to find the minimum value of this expression. That's a of x equals 16x squared plus 4,000 over x. We have to find the minimum value of that. Well, that means we have to find the stationary point on the graph of this function and show that it's a minimum stationary point. So we'll need to have a look at differentiating the expression. So this is part B. We're looking at the function a of x, 16x squared plus 4,000 over x. And we're looking for a stationary point in this. So let's differentiate a dashed of x. Now, is it in a form that we can differentiate? Not quite. We'll need to bring this x to the power of 1 up to the top of the fraction to join the 4,000, so it'll become x to the negative 1. Now it's in a form we can differentiate. So differentiating 6x squared gives us 2 times 16, that's 32. Bring the power down and multiply 32x and reduce the power by 1. Bring this index round to the front and multiply, so that's negative 1 times 4,000, and then take 1 away from the index, negative 2. So we end up with 32x minus, and let's take that negative 2, that x, the negative 2, let's take it down to the bottom of the fraction, and the negative 2 will become a positive 2. So there's our gradient formula, and we know that to find stationary points on that graph, the graph of this function, for stationary points we'll need to set that gradient formula, a dashed of x equal to 0. So I have to find values of x for which 32x minus 4,000 over x squared is equal to 0. Well, let's get rid of the fraction first off and multiply both sides by x squared. So we'll get 32 x squared times x is x cubed. Minus, we'll just be left with 4,000 when we multiply it by x squared. And x squared times 0 is just 0. So we're ending up with 32x cubed equaling 4,000. So x cubed is 4,000 over 32. And we would need to take cube root of that, and unlike the square root, there's only one value, a positive value. X would be the cube root of 4,000 over 32. Now, there's a bit of cancelling goes on here. 4 8s are 32, so let's do that before we attempt to do the cube roots. So we divide top and bottom by 4. And now we can see the answer. The cube root of 1,000 we know is 10, and the cube root of 8 we know is 2, so the answer is 5. So there is only one value of x that gives a stationary point in that graph. Is this a minimum stationary point? Well, let's draw a table of values. So there's a number line with x, the value of x being 5. Let's look at the value of a dashed of x. Well, we know when x is 5, we know that a dashed of x has a value of 0. Now, what happens to the left of 5 when x is a little bit smaller than 5? Suppose it was 4, for instance. Let's go up to this a dashed of x. This is the gradient. And let's look at this expression. Now, we know that 32 times 5 must be the same as 4,000 over 5 squared to get a 0. So if we're making this value smaller than 5, because we're dividing it into this, it'll go more times, so we'll be subtracting a larger number from this 32x, so we will get a negative value. Check in your calculator, put 4 into this, and you'll discover a negative value. Likewise, if we go to the right of 5, remember 32x minus 4,000 over x squared is equal to 0 when x is 5. So if we increase this value bigger than 5, it'll go into 4,000 less times. So we'll be subtracting a smaller number, and therefore we'll get a positive answer there. Again, check on your calculator by putting 6 in, for instance, and you'll get a positive answer. So we're looking at the shape of the graph now as negative gradient, so it goes down, 0 gradient at x equals 5, and then positive gradient goes back up. So find the minimum value of a. So what we can say is when x equals 5, then a has a minimum value. And it just remains to put 5 in to a to find what that value is. Well, let's do that over here. We put 5 into the surface area formula. We get 16 times 5 squared. There's the formula up here. Plus 4,000 over 5. Now that's 16 lots of 25. 4 lots of 25 is 100. So that'll be 400, and 5 into 4,000 is 800. So we're getting a value of 1,200 square centimetres. So that's the minimum surface area for a box of this kind that has a volume of 2,000 cubic centimetres. That's Mr. Corsi signing out. Hope you enjoyed the video.